last day of DevCon. I'm Lucas, and today we're going to talk about how to implement high availability in the cloud. So first, I'm going to introduce myself. I'm a software engineer here at Red Hat. I'm currently working in the Red Hat OpenShift data science platform. In upstream, it's called Open Data Hub. Both are the AI services of OpenShift right now. And in a little note about myself, I love music, I play several instruments, and I love toying around with new technologies. So, should we start right now? Okay, first of all, what is high availability? Okay, so the term high availability, it's pretty much self-explanatory. It's the quality of a service that ensures a high level of operation and maintenance. It's expressed in a percentage, and it indicates how much uptime is expected in the services. For example, if you have a service that is expected to have a 99% of high availability, it means that in a year can have up to 3 days and 15 hours of that downtime a year. It's roughly 15 minutes per day. For example, in our services right now, we're aiming for a 95% of high availability. That roughly translates in 4 hours and 22 minutes per year and only 43 secs a day. First of all, we need to bear in mind that the most important thing to ensure high availability in our services is just to identify all the single points of failure in our service and try to fix them. And then try to ensure every other feature that we need to have to add high availability, such as redundancy, low latency in recovery, and a low amount of single points of failure. Okay, so right now I'm just gonna get through some of the components we have in our platform and how we implemented high availability at the time we needed to release the general availability version. So we're going to discuss how we implemented this high availability in the Jupyter Hub service. First of all, what is Jupyter Hub? Jupyter Hub is a platform, the lead platform to serve Jupyter Hub notebooks. In a quick note, Jupyter notebooks are web applications for create and share computational documents. Here, data scientists could use this platform to create their own notebooks and then they do their own experiments. For example, creating new Python researches with models and these kind of things. All the components in Jupyter Hub can be adapted to fit into our services. So right now, we are currently seeing here the architecture of Jupyter Hub as it's shown in the web page. And here we can see it has an HTTP proxy, the config by file, an authenticator to decide whether a user is authenticated or not, these spawners that spawn new notebooks and manages the serve and the creation and the deletion of these notebooks. And then an admin section and a database to ensure persistence. So with this service, we adapted the version of OpenShift and did our own wrapper about all the documents. For example, right now we are using the out proxy of OpenShift as authenticator, just to ensure it has the same compatibility with the OpenShift platform. We are using, instead of the ATCD HTTP proxy that Jupyter Hub uses, traffic. We're going to discuss it later, why are we using that. For example, for the database, we're using AWS RDS or PostgreSQL if we are in local as a database. And we have an inbuilt spanner that we created just to ensure we are creating notebooks in our own namespaces and we create our own rules for that. So first of all, we're going to talk why we replace the inbuilt proxy with traffic. First of all, traffic is the cloud native application proxy. It's a reverse proxy and a load balancer. That means that it redirects some of the requests and it can serve as a load balancing of all the requests that the users made in our platform. They intercept routes and every request based on rules. That's important. That's one of the reasons we started to use that. You can create pretty much every rule, and traffic could read them and apply it in the traffic that it's trying to manage. So, for example, in our component, we're using traffic to write rules to redirect the traffic to the spawn notebooks. So our main problem here is that we had some notebooks that were spawned, and we wanted to outlive the Jupyter Hub services. For example, if we had some sort of failure, if the Jupyter Hub service restarted or something like that, we needed persistence just to be able to access these notebooks after the reload. That's why we changed the ATCD inbuilt proxy with the one we are right now trying to use. As you can see, this is the architecture of our platform. As we discussed, we have the traffic proxy and then the Jupyter Hub server. Here you can see the user use the OpenShift access just to go to the traffic, and here we accessing to the platform, we have a service for the traffic proxy that it's currently detecting all the traffic of the service of the Jupyter Hub server. So what I'm doing here? When we're trying to access the service of the Jupyter Hub server, the traffic proxy, it's in the middle, yes, redirecting all the routes, and we have in the middle a config map in which we write all of our rules. At first, when we start the service, if the config map is not created, we create a new one with the default routes. And inside this Jupyter Hub server, we have the custom spawner. And with this custom spawner, every time we create a new notebook, it will write new config map rules just to have that as we previously discussed. So when we're trying to access, for example, this new notebook, the notebook one, for example, it will read the config map, it will read the name, and it will know which IP need to access, and we can go there. So, for example, if the Jupyter Hub server dies in a matter of seconds, or it happens something, it will try to redirect, and it will go to the notebook selected, even though, for example, the service it could have died. So yeah, that's more or less the current architecture that we are using here. So for ensure high availability, the things that we did, first, it was horizontal scaling the traffic proxy. In case some of the pods died, we could have every other pod just to start and get the new lead. We did the same. We created an horizontal scaling of 3 pods with the Jupyter Hub server, but we had a problem here. Instead of doing a regular rollout with everything, we started to use something called leader election. A leader election mechanism, it's one method of high availability in which we decide that only one of the pods is acting as a leader, and it's the only one working at that time. Why we did that with the rules that we were writing, we needed only one pod to be up just to then redirect everything to the notebook. So with the leader election, we had the advantages of having multiple replicas at the same time, but we had the advantage of having only one service and then simplifying all the rerouting and all the traffic that we were having at that time. So that's one way we ensured that we had a replication with traffic and Jupyter Hub services. we have persistence just to have everything um, outliving the restarts, and we have replicas for have the low latency when a service died or a service restarted. So here with everything, we can go to the demo part. Okay, so as you can see here in the traffic demo, we have here all the pods of traffic. There are 3 of them, as you can see in the application. These are recurring workers. We have the Jupyter Hub service, the traffic rules config map, as we discussed, and then the Jupyter Hub service. We're going to start a new server just to create a new notebook inside Jupyter Hub, and here you can see that we are waiting for the service to be created. Right now, it's being created here, the Jupyter Hub idle coder and the Jupyter Hub notebook. So we are creating here the new notebook. It will be created in another namespace called ODS application notebooks. And once the notebook is created, we'll have a new service. If you see here in the traffic rules config map, we have added a new rules just to access this new notebook. So then traffic can can access every time, and we have some sort of persistence here. Right now, we are just creating a new notebook. Here you can see it can run Python. I'm saving that notebook. I'm gonna close that. As you can see, if we access that again, it will be at the same state. Now we have this print hello world. But then again, if we do the following right now, we're gonna go to here we have traffic rules. We're gonna go to the Jupyter Hub service. Here we have the Jupyter Hub service, and we're gonna just delete the new one. So we have deleted the new Jupyter Hub service. We are creating a new pod, so the leader elected it's changed. So you can see here when ready, it's 2 of 2. We have selected a new leader elected. It's easily created. And right now, even though we have deleted the service, the notebook we can access the same notebook as it's persisted in the config map. So even though our services could be restarted or something like that, or we can have a new rollout, or we can have pretty much everything else, we will have a failsafe in which we can access all of our notebooks. And that's one way we ensure we don't have these kind of problems. Then again, we use the leader election to just ensure some replicas in the Jupyter Hub. As you can see, we are using a sidecar container in which we have the image of the that is currently electing the leader, and then we have the Jupyter Hub. So here it's the running terminal of the Jupyter Hub, and then we have the sidecar in which we see that we have a log mechanism, and with this log, it will decide a new leader action once the leader dies. So here you can see that the other one is waiting to become leader, and here we all of them share the same log. So once we have this Jupyter Hub leader deleted, we will start to have a new election mechanism. Right now we're 15 by running, but here we have all 3 of them running, and we can see that the new Jupyter Hub 1 RXS is elected. So in a matter of seconds, it will become leader. So right now we can see the logs that it's currently running, and we have the service up and running in a matter of seconds. Without needing to create a new pod, create a new running, and this kind of thing. So it's ready to go, but it's just in idle, and it's not intercepting traffic as we have the rules of that. So here we have the techniques we use to ensure high availability in the Jupyter Hub service here in the cloud, in OpenShift, and it's more or less everything we needed at that time, and it has served us well for about a year. We had some lessons learned with this kind of implementation, as it was our first time implemented something with a leader election mechanism and trying to have this kind of root mechanism. So first things are the lessons learned. So first of all, simplify things. For example, when trying to implement the leader election, we started using an old and complex sidecar image. Well, has some example of that, and one of the techniques is using a sidecar image. We use this because we didn't want to add more complexity to the user have image, so we decided to have a sidecar container just to have all the logic in with a inside this sidecar container, and in you have all the adding a startup script that it was easily maintainable. But first, we started to use that image of Google, and we ended up scraping that for a simplified version since it had so many things, and as it was very complex, we had some problems and drawbacks just trying to implement in our solution. So we ended up having a simplified Golang version with a Golang library, and just having the most simple solution with one lock, and just trying to get everything with our bots. So the second one is think about the SRE. For example, always think about all the single points of failure of your service. One of the reasons we use config map instead of an inbuilt solution or some sort of persistence, the config map was distributed by OpenShift in every other cluster. So if one of our cluster was down or had some problem, it had an inbuilt solution to recover it. And that's why, for example, you won't even have your database in the same cluster as your service, or you will have all of your persistence distributed among several clusters. Because in case of recovery, in case of disaster, you can recover, or you can have a load balancing service, which you can then redirect all the traffic to a healthy cluster. So it's very important to think about every other single point of failure, and then just try to apply the best solution for that. And just think that everything will break. So insert redundancy everywhere it's possible. That's why in our main service we ensure that we have several replicas, and in case one of them was restarted, we try to aim the least amount of downtime as possible. It was impossible, for example, in the Uber service to have a 0 seconds downtime, but we reduce that as much as possible with a custom rollout and trying to figure out everything out with a little action. But as we had this lesson learned, we bumped into several issues as we start to deploy more features and refine the redirection mechanism and this replication with this architecture. For example, the custom rollouts. We started implementation of custom rollouts due to the leader election complexity. As we have a new mechanism just to have everything right together, we started to have the readiness probe for our bots, as it was impossible for Kubernetes and OpenShift to decide where to redirect all the traffic. So we needed to have a custom rollout, and then have two pods in middle in the three replicas, two pods in middle, and only the leader election be running with everything all together. So this at first sounded great, but it led to several issues, and he spotted several things that were wrong with our implementation at first. Because when you start to implement complexity, it can lead to several issues that you can spot in development time, or maybe if you have that back, you will spot it in production. Our other problem was the downtime in products. As we didn't want to implement the leader election mechanism in the main image of user hub, because at that time was the best possible solution, we spot that we have an acceptable downtime in the rollouts due to changed waiting times. So, adding the time of the lead election mechanism, the time that we had with the sidecar uptime, the sidecar continuing uptime, and the time that user have needed to start, we started to add a chained time that it led to some problems with the SLO we had to the 99.95% of the time. So the custom rollout sometimes led to problems with the, for example, in upgrades or updates of the cluster that it could be so slow. It would trigger some alerts because the services were down more time than it was acceptable. And apart of that, we introduced new dependencies. With this custom code, we created new dependencies that added potential issues as we previously discussed. So always if you try to get something that it's implemented manually, you will bear in mind that it's code that you need to maintain, and then it could induce some errors. Um, right now, we discover new ways to improve our architecture. So that's been like, believe me that this previous architecture has served us well for a long time, and it's a great way to approach this kind of high availability. Right now, we are using a new kind of technique, and we, like, full disclosure, we are trying to deprecate this architecture because all of the issues we have discussed, and that there are new ways to do that. Right now, we are using the Qflow notebook controller. That is the Qflow implementation of the notebook, just targeted for the cloud. Because the main problem with our implementation that you have, it's a local program that it was rewritten or adapted for the cloud. So this is a built-in native solution for the cloud, and that ensures us to have more replicas, not using these kind of custom techniques, for example, this routing traffic or this lead election to ensure high availability. And we can simplify things just to making some sort of API calls to this notebook controller instead of maintaining all the code of our own implementation. Just having this notebook controller that it's maintained and adapting all the parts that we need for that. So right now, the user with OpenShift will log into the dashboard, and the dashboard will communicate with the Kubeflow notebook controller via APIs. And with this, we can spawn new notebooks, we can control them, delete it, and all the features that we previously have with the old implementation, and ensuring we have multiple replicas, we have storage, we have persistence, and we have everything else, but reducing the complexity of our architecture. And that's more or less everything we have right now with this. Here you can see the resources in the slides. We can attach this to the talk. And if you have any questions, I'll be around here. I will connect from Spain just to answer some of your questions. It's been a pleasure. Yeah, sure. Perfect. Thank you very much.
I'm quiet. Do I need to project or do? They're going to turn me up. Okay. Well, for some reason, my mouse doesn't want to pair again, so I'll use the touchpad.
Okay, I think we can get started. Okay.
Well,
Welcome to DevConf US 2022, and you're in conference auditorium. Let's welcome the speaker of this session, Ingrid Toy.
what? Do you turn me up? I'm up. Okay. Great. Is it time to start? Yeah, okay. Hi, I'm Ingrid Towie. I am a technical editor and writing coach at Red Hat, and I also have a background in user experience design. Now my mouse is connected. Woo. Welcome to Science Fiction is all around us. TV shows like Star Trek, movies like 2001: A Space Odyssey, and Star Wars have had a tremendous influence on our culture and on our user experiences. Many of you remember the Star Trek communicator. Well, not only did we all want one back in the 1960s, it's had a huge influence on our tech. Remember the Motorola flip phone? Well, that was based on the Star Trek communicator, and it was even called the Star Tac. Who knew? I know now. Now, the Dick Tracy wristwatch was very popular for anyone who read who read the scripts with his video phone. And here it is being used on a smartwatch. Very similar UI, very similar look and feel. Now, the Amazon Echo, the Amazon Alexa, and the Google speech interfaces are very similar to the interfaces used in Star Trek. And one of the more important things to remember is that we tend to anthropomorphize our technology, even if it doesn't have a face, doesn't have...
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
Just like we did in 2001: A Space Odyssey. And here we've got a video screen because it's a video call from Red Hat. And I'll tell you, this used to be like most outrageous science fiction, and now everybody does it. In 1968, when 2001: A Space Odyssey came out, it was just an outrageous science fiction that we could actually have that. Now, one of the things I love about this is that the 4-year-old actress is spot on for every young child I see in a video call. The squirming in particular is just perfect.
Where's Mommy? Who's taking care of you?
Rachel,
Can I speak to Rachel, please?
go to the bathroom. Are you coming to my party tomorrow?
I'm sorry, sweetheart, but I can't.
Why not?
Well, you know, Daddy's traveling. Now take care and be a good girl, won't you?
All right, bye-bye.
Bye-bye. Happy birthday.
You'll notice this 4-year-old didn't actually need a user manual. She didn't need any instructions to use this complicated interface. So what we're going to talk about today is how has science fiction influenced past designs? We've already talked about that. What are some current trends in design that come from science fiction? And when is it innovative design and when is it actually stagecraft, something that moves the plot along? And when do science fiction designs take advantage of the way humans actually think? What's really next in user interface design, and where can we see it? And finally, is this really the future that we want? Is this the way we want to design our future? One current trend that we see a lot in user interfaces, especially in science fiction, is this kind of semi-transparent, transparent interface where you can see through it. Now, the real advantage is really stagecraft. You can see both people's faces when they have a conversation, even though they're not both in the room. One's remote. That's like you see in The Expanse. And here in The Expanse, you can see his face even as he works on a diagram. And here you can see Tony Stark working on a diagram. Now, in Upload, you'll notice that instead of being projected onto a piece of glass or a piece of plastic, they actually are using their fourth finger and thumb as their screen. Now, what you'll mostly notice about these interfaces is that they really work well for stagecraft. You can see people's faces through them. You can see their emotions and their interactions. I mean, there is some advantage for anybody in being kind of staying grounded in your physical space while you're working on a computer. But in reality, there are a ton of accessibility issues. If you're neurodiverse, if you have visual issues, this would be very hard to read and understand and stay focused. So where are we actually seeing these kinds of designs in current UX? One is this concept of glass morphism, which actually isn't new. It started with Windows Vista about 10 years ago, but used a ton of processing power. And people just really didn't like it. Well, it's being reinvented for the Mac OS Big Sur. And the advantage of it is that when a window pops up, you don't lose your context. You can still see what's going on underneath it. But again, there's a lot of visual noise. So we have to decide whether it actually works. Another thing that we see a lot in science fiction is gestural interfaces like you see on your Android phone or your iPhone. You'll see in this clip from Castle that he's pinching, he's swiping, he's dragging, just like we're used to using on an iPhone. In a lot of ways, though, the future is already here. The LG 55 looks very similar to the screen in Castle, and you'll see that people are doing those same gestural interfaces. Also true in the Minority Report. He does the same swiping and pinching and those kinds of things. There's a real moment of comedy here where Tom Cruise reaches over to shake the character's hand and he almost loses everything on his screen. So when you're dealing with gestural interfaces, you have to think about the fact that unintended gestures can have real consequences. In Ender's Game here, the gestural interface is being used to tell the story and to expose people's inner thoughts. And so that when you're looking at the screen, there's more than just the screen. You see people's faces. You just see all that kind of emotion through it. But these kinds of backward-looking UIs are inherently dangerous. They can look as dated as the Macintosh and the mouse did to Scotty and McCoy in Star Trek: The Journey Home.
Computer? Computer? Ah. Hello, computer.
Now, sometimes we do see like really innovative uses of gestural interfaces and see-through interfaces. In The Expanse, you'll see this character swipe an image from a clear sort of phone onto a big screen to do a search. And that's kind of cool, but it also is showing us the progression of the plot as they search for a missing child. We have to be really careful when we look at and use this Hollywood pigeon, or our designs will look as dated as the phone booth did in 2001: A Space Odyssey. One of the things that's really interesting about our video calls now is we don't need a picture phone booth. We don't need any kind of phone booth because everybody carries a screen in their pocket. So when do science fiction designs work like humans think? Sometimes they do something really special, and they take us out of our two-dimensional, pixel-based, paper-based world and allow us to think like we really do think in 3 dimensions, in the physical space. And when they do that, that's really incredible. And that's one of the things. So I'm going to talk a little bit about evidence boards or murder boards, which expose the way people think, and they're used a lot in science fiction, murder mysteries, all kinds of things like that. In this case, this evidence board, or this big board trope, actually is showing little pieces of paper that represent the entire design up to that point, not the entire design, the entire plot. And they expose all of that to the main characters. So they're used for exposition, and they also just bring everything together in a wonderful kind of way. Now, this is because this is the way humans think. And sometimes in science fiction, we see that with volumetric holograms or 3D projections. They're like a version of these evidence boards, but they're done in a different kind of visual space. And that's because they're taking advantage of the way humans think. In this scene from The Expanse, the pilot Alex is trying to plot a course through all kinds of defensive mechanisms around Ganymede. And he can't do it in 2D, so he resorts to a 3D simulation, trying to get around the ships and the different sorts of things. And then he adds time or motion to finish with his projection. And then he's able to actually...
Time lapse times 10.
Plot the gravity assist trajectory down to Ganymede. No engine, just thrusters. Right. Well, no one said it was going to be easy.
Now, in this case, you see a multi-user interface. That's a 3D projection or volumetric hologram. These two characters are working together. In the next scene, you'll see a bunch of school children working on a 3D projection. And this is a way that they can all work together and get trained without a user manual, without any kind of documentation. It's all in the interface. Now, if you think about it, they're trained here playing the game, and then when it's time to use a space dock or a spaceship, they already know how, because they've learned how to do it with this game. These 3D interfaces lead to collaboration and connection. They unite us, and they allow us to work in a new way. Now, it's true that we can project a keyboard that we can use with our smartphone. You can get that at Walmart. But in general, these kinds of interfaces are just not available without virtual reality gear. Now, curved displays are another way that science fiction uses displays that are the way humans think. You see, it takes up our peripheral vision, a curved display. It just totally immerses us in that world. So in this case, Artemis in Ready Player One is in this curved display in a console chair. In the next scene, you'll see Christian and Bobby from The Expanse in a curved display in the Razorback ship. See how the screens come up? Augmented reality is another thing that you see some in science fiction, and it's probably really where we're going. Augmented reality, we all saw that with Pokemon Go, and it was tons of fun, but it used up your phone battery, boom. So it was hard to use. We didn't really want to use it very much. But in science fiction, you can think about things like augmented reality and not have to worry about battery life or processing speed. Take this clip from Spider-Man, Far From Home. He's using the Edith smart glasses, and this is a really cool kind of version.
Say Edith.
Stand by for retinol and biometric scan. Retinol and biometric scan accepted. I have access to the entire Stark Global Security Network, including multiple defense satellites, as well as backdoors to all major telecommunication networks.
Whoa.
Now, Microsoft Mesh is actually beginning to have this same kind of augmented reality, but with virtual reality gear. That's the one problem.
So this next. Look over here.
Challenge us with new ways of seeing.
Now, UX designers have partnered with Hollywood, and one of the things I found out when I was doing my research was that you can get a job doing UX design full-time for movies and TV, and I'm like, yes, that sounds like the perfect job. And in the MIT Media Lab, not too far from here, partnered with Steven Spielberg for the Minority Report. And that was a case where professional UX designers were actually creating the design for the movie. Now, I know that this particular movie is 20 years old, but it's still playing out today. And if you think about it, the MIT media designers had millions of people as focus groups to see if their designs actually worked. They've actually founded a company today to make these designs a reality because they help people think better. Large-scale, high-resolution displays help people to process information more efficiently, 10 times as quickly, and to do pattern recognition 2 to 3 times as quickly. Now, in a smaller display, people can make connections and do those kinds of things, but they tend to use much simpler strategies. One of the things to remember about the display from Minority Report is that Tom Cruise actually found this exhausting. Apparently, holding up your arms at chest level doing these big gestures looks great in a movie, but it's hell on a human body. It's just exhausting. So what's actually next in UX? I love these UIs that I showed you, but I think the future is going to be a little weirder than that. Now, the bridge on a spaceship, you see this in movies a lot, TV shows. It's like one station, one person, it's all dedicated. But when our iPhones can do something as complicated as be almost anything that we want them to be, why shouldn't workstations work that way too?
Storm's getting worse.
We'll pass through it soon enough.
So these were all standard kind of bridges and workstations, but in the future, we may actually have an artificial intelligence or an android that pilots the ship as they do in the next scene from Dark Matter. The android, the blonde woman, is actually totally fused with the ship in terms of her brain.
For now, I need you
And
to
she
run a full
pilots it.
diagnostic and restore all systems. All right. No. Show me.
All right. It will take some time to repair them all. Do we have engines and navigation? Yes. What about weapons? Ship's weapons are down. Then let's make that our next priority.
All right. No. Show me.
Or how about the hybrid in Battlestar Galactica? She is actually physically fused with the ship, and she pilots it through hyperspace.
She is the spaceship in a very real sense.
Michael, that.
She experiences life very differently than we do, guys. She swims in the heavens, laughs at stars, breathes in cosmic dust. Maybe Leovin's right. Maybe she does see God. We're wasting time. Jump.
Augmented humans are also something that you see in science fiction, and it's probably likely in our future. It's probably going to start with people who need to see or hear or walk. But eventually, we may have augmented humans like this reporter in The Expanse, whose eye is a camera, and she stores video clips that she takes with her eye in her brain.
Your organization leaks like a sieve.
Did you know about this? No.
According to my sources, Cortazar was taken from a secure research.
Now, right now, you all are familiar with retargeting because we live with it all the time. The internet knows everything about us. Whenever I open my favorite blog, Ask a Manager, I get retargeted for Red Hat Marketplace because the internet knows I'm connected to Red Hat, okay? Well, in the future, the walls will know our names.
Hello, you're on John Anderton.
I mean, they're calling John Anderton over and over.
You can move the old-fashioned John Anderton. Gourmet cuisine. John Anderton. You could use a Guinness right about now.
Stressed out, John Anderton.
Escape from it all, Harrison. Get away, John Anderton. Forget your troubles.
Is this really what we want our future to look like? Do we want a world where Google or Big Brother is everywhere? Do we actually want this dark future where we've invited Big Brother into our lives, where every action that we do is tracked? When this ad came out in the Super Bowl in 1984, Apple was talking about the introduction of the Macintosh and how it was going to free us from the tyranny of tech giants like Microsoft and their user manuals and their CLIs. Do we really want a dark dystopian future like this one?
We shall prevail.
So if you want access to any of the resources that I used or want to know more about the clips from the different TV shows I used, you can just scan the QR code and that'll take you to a folder that has, well, actually it'll take you to a Google Sheet, a Google presentation doc, whatever that's called. I can't, it's slipping my mind. Does anybody have any questions? Yes, Karsten? Yeah, slides, thank you, slides. Questions? Yes. Oh, somebody's bringing you a microphone.
So I'm curious, you mentioned something about neurodiversity. I have autism and ADHD, by the way, and I'm curious about the interfaces that science fiction shows that impact neurodiversity. Any examples of interfaces that how they could be allow neurodiverse and other people, and also for all people, or is this just going to stay in the fictitious world, in the fictitious realm?
Well, I do think that people are becoming more aware of the need to make systems more accessible for people who are neurodiverse, because I'm hearing about it a lot. It's not just about visual impairments and making sure that things work well with a screen reader. I'm hearing a lot about, well, you can't do that because it's hard for people with ADHD. So I think we actually are making progress in that area. It could be that part of it is just making these kinds of interfaces, even the ones that we see in science fiction, very customizable so that people can make them work for themselves. And it could be that some of these augmented humans, some of the computer-human interactions where computer and human are one thing, there might be ways to help neurodiverse people with that kind of implant. Especially when you think about computer-human interaction, where computer-human is a compound noun. It's kind of a cool thing about an augmented human. Okay, Karsten has a question.
Thanks. Ingrid, I have to say in person, best presentations I've ever been in front of. So thank you very much. That was fantastic. And you got me thinking about a lot of things that I hadn't thought about before, but in certain ways. And so in that vein, I'm with the concept that science fiction is often, or with the concept of science fiction often is used to make a statement by the author. The science is its own character and has its own, just in a literary sense, right?
Oh, yeah.
Yeah. And so then, in that, are there examples of where the user interface, I was just imagining like using that as a way to advocate in your science fiction for interfaces for neurodiversity, or are there examples where the interface, where the author is deliberately, that you can think of, has deliberately done something with the interfaces that is part of the statement that they're making in the science fiction? I feel like they even had an example go by maybe, but I can't quite think of what it was.
Like where people are making a statement with their UX?
Yeah, the statement that's maybe related. Since it's part of the science, and yeah.
Yeah, well, that's definitely true with 2001: A Space Odyssey. They were making a lot of statements about the future and I do think that with that one particularly, you see Hal, and he has this whole personality, and yet you never see a face. You never see anything that's even faintly face-like, and yet he's as much a character in that movie as anyone. So I do think that that's one way that that particular movie is making statements. It's probably true for every movie if I thought about it. As an English major, eventually I could tease all this out.
We have only one minute left, so this is probably the last question.
For the augmented humans in particular, and the humans did not evolve to have implants built in with computer-based implants built in, like cameras and some sort. So what are the medical impacts of this, and how will we as hardware developers and even the physicians, how will they deal with it? Because human beings are not designed to have computer hardware built into them. But if that becomes a reality, how will we deal with the medical kind of issues that causes?
Well, it's actually already a reality. People already have little chips that control their heart, things like that. I mean, one of the big issues is that a lot of that type of hardware is hackable. And I think one of the things that humans who are in our field of UX design and software design, they really have to think about the security issues so that people are not being held for ransom. It's like, I'll stop your heart if you don't give me everything in your bank account. So yeah, we have to think about those security issues because it's already out there, and that's probably a really big thing we have to think about. And humans weren't built for cochlear implants. They weren't built to have glasses. They weren't built to sit all day. We were probably built to, if you want to think of it in sort of Darwinian ideas, we were built to, live outdoors and do a lot of things that we don't do anymore. So I think this would just be one more step along that path to a very different future from humanity's past. I think they told me that was the last question.
Yeah, time is up. Thanks, everyone.
Thank you.